So, good morning, everyone, and welcome to today's lecture. This is lecture number 2, and we are dealing with the topic of units and dimension. If I go back and have a look at what we had covered in the previous class, we had covered what is a unit. We had seen unit is nothing but a comparison standard which is used to compare physical quantities. Only those physical quantities which can be compared, which are same. You can compare time with time, mass with mass, but you cannot compare time with mass or any other quantity which is different. When you are comparing these quantities, they must be in the same unit. We saw it with the example of that alien coming to us and asking us which is smaller and which is larger, and we could not say because we did not know the conversion factor. So let us move ahead and get into today's class. In previous class, we had seen that the physical quantities can be classified into scalars and vectors. Now, in today's class, what we are going to see is one more classification of these physical quantities. So, if I may write physical quantities, we already know what is a physical quantity. Yes or no? What is a physical quantity? Anyone? What is a physical quantity? A physical quantity is a quantity that can be. The mics does not work. Is it working?
Yes, sir.
Okay. Yes. The physical. What is the physical quantity, beta?
Quantities which are measurable are called physical quantities.
Correct. Quantities which can be measured are known as physical quantities, scalars and vectors. One classification we have seen. Now, today we are going to see the next classification. Now, this physical quantity can be called as a fundamental or base quantity. I hope everyone will write together with me. You can classify them as fundamental or base or absolute quantities. That is the first branch. Then you can call them as derived quantities, or you can call them as supplementary ones. Supplementary quantities. Now, the question now arises, what do you mean by a fundamental physical quantity? Now, if you have a fundamental physical quantity, you will also have a fundamental unit. Let us first understand, what do you mean by a fundamental physical quantity? Can anyone help me in telling me what can I mean or what can I understand by this fundamental or base physical quantity? Anyone? Anyone knows? If you can raise your hands. Yes?
Sir, hello. Good morning,
Yes,
sir.
beta.
Sir, fundamental physical quantities are length, mass, time, sir.
Length, mass, and time are fundamental quantities. That is correct. But can you define what quantities? You have given me an example. You've given me the example of fundamental physical quantities, but you have not defined it. When I say you have not defined it, you have not told me the definition of a fundamental quantity. Can you tell me the definition of a fundamental quantity, beta? When do we call a physical quantity a fundamental physical quantity? Hmm. What do you mean by a fundamental physical quantity? Example has been given, length, mass, time. There are more examples. Anyone knows what is a fundamental physical quantity? Please raise hand. No one knows. Okay, that's not a problem. You are not supposed to know it because you probably have not heard this word or heard this term. A fundamental physical quantity is a physical quantity which cannot be derived from other quantities and which has an independent existence. So, a fundamental physical quantity is a quantity which I hope everyone will write. which cannot be derived. It cannot be derived from other quantities, and it has an independent existence. So it exists independently. A fundamental physical quantity is a quantity that cannot be derived and it exists independently. Now we get into the examples of this, but before getting into examples of this, let us see what would be a derived physical quantity. Now, if you know what is a fundamental physical quantity, you can tell me what would be a derived physical quantity. And the meaning is in the word itself. Now, can you tell me what would you mean by a derived physical quantity?
Sir, the quantities which can be derived and they are dependent, sir.
Yes, it's exactly the opposite of a fundamental physical quantity. Derived physical quantities are all those quantities which are not fundamental. That means they are derived from each other. They can be derived from the fundamental quantities. They can be derived from other quantities. They are known as derived physical quantities. Fundamental physical quantities, if I give you some examples and then we'll move ahead. Mass, length, time. These are the three important examples that you all know. You might have heard about it. So let us start with these three. Mass, length, and time are the three fundamental quantities. Are there only three fundamental quantities? Or are there more fundamental quantities? What do you think? Are there only three fundamental quantities? Any idea how many fundamental quantities are there?
Sir, 7, sir.
Sir, seven, sir. Yes, that is correct, sir. There are seven fundamental physical quantities. But before getting into those seven fundamental physical quantities, we as human beings have evolved. Slowly, we have evolved. There was a point in time when we discovered fire, when we discovered the use of the wheel, and we have been evolving. Not many years ago, we thought that with only three fundamental quantities, with only three fundamental quantities, we can describe all the physical phenomena that we see. So, previously, whatever systems we had, they consisted of only three fundamental physical quantities. And those three fundamental physical quantities are right now on your board, which are being highlighted in yellow. Length, mass, and time. These were the three fundamental quantities. And we thought that with these fundamental quantities, we can explain all the physical phenomena, which is obviously not correct. Now, based on these three fundamental physical quantities, we had different types of systems that use those fundamental physical quantities. Do you know what those systems were? Number one, what was the first system which was based on these three fundamental quantities known as? You must be knowing
System,
it.
sir.
Which
MKS
one?
system. MKS system, sir.
MKS system. Very correct. MKS system of fundamental quantities, or MKS system. It had only three fundamental quantities. M standing for what?
Sir, meter, sir.
M standing for meter. Yes. K standing for?
Kilo, sir. Kilo.
Not kilo. K standing for kg, kilogram, the fundamental quantity for mass. And S standing for?
Second, sir.
Second, sir. Yes, this was the first system that we created, which was known as the MKS system, in which we had three fundamental quantity. For mass, we had kg. For length, we had meter. And for time, we had seconds. That was the first system that was used. Can you tell me what was the other system that was used?
CGS system, sir.
It was known as, very correctly, the CGS system. Now you can tell me what were the Units
Sir,
that were used in this system:
sir, centimeter,
centimeter,
grams,
gram,
second, sir.
and second. These were the three units: centimeter for length, gram for mass, and seconds for time. Three were good enough to describe all the phenomena that could be seen. There was one more system that was in use, still it is we use somewhere, which was known as the
Yes, sir. Sir, foot, pound, second, sir.
FPS system. Foot or feet
Pound,
for length, pounds. Pound, not the British pound, which is money as well. It was the British pound for mass, and S standing for seconds. We can see one thing very common here. Whatever the units were, for time we only had seconds, and that is something great. MKS, CGS, and FPS. These were the three prevalent system, but there was a problem with this system, and it, it became exponentially big. Now every country was using its own system. Some were using MKS, like some were using CGS, some were using FPS. America was using its own FPS system, which had miles and all these things. Now there was a fundamental problem with all these systems was that as world expanded and more countries they started to collaborate with each other, there was a problem. If I am talking in MKS system and the other one, the other gentleman from other country cannot understand that MKS system, he understands FPS or he understands length in miles, he understands speeds in miles per hour, it became somewhat difficult for
hello, sir. Hello.
collaboration to take place. Yes, beta.
Sir, I have a doubt, sir.
Yes,
Hello,
just a
sir.
minute. Wait, 1 minute. So there was a need to manufacture or to find a system which was universal, and that system came to be known as number 4, which is the system that we use, and that is known as the SI system or the standard system. Now this standard system was derived from which one? This SI system was
From
derived from
MKS,
which
sir.
one?
From MKS,
It
sir.
was derived from the MKS system, because most of the countries were using this system, apart from a very few which were using FPS and a very few which were using CGS. So what they did, okay, majority of the countries are using MKS. Let us make a system based on MKS. And here came the system that we are using right now, which is known as the SI system. But then we realized that only three quantities are not good enough. Only three fundamental quantities are not good enough to describe everything that was present. And therefore, this SI system has how many? It has seven fundamental quantities. It has seven fundamental quantities plus two supplementary quantities. It has seven fundamental quantities and two supplementary quantities. That means it has seven fundamental units and two supplementary units, because every fundamental quantity will have one unit. That unit is known as the fundamental unit. There are seven fundamental quantities and two supplementary quantities. Yes, now you ask me what doubt you have.
Hello, sir.
Yes,
Sir, there you written FPS, na, sir. That F stands for foot or feet, sir.
doesn't matter. We call it foot or feet. It's actually feet is the plural of foot. So you can call it foot. Foot is the singular quantity, 1 foot, 2 feet. So
Okay, sir.
So now we have seven fundamental quantities and two supplementary quantities, or seven fundamental units and two supplementary units. Do we now know what are those seven fundamental quantities? Does anyone know it? Can anyone tell me What are those 7 fundamental quantities? Anyone? You must be knowing it. I know that you know it. No one would like to say? See, there is no right answer and no wrong answer. Remember that.
Hello, sir.
Yes, beta. Tell
Sir,
me.
can I try, sir?
Yes, try. Yes, beta, try. Tell
Sir,
me.
sir, first one is length,
Length,
mass,
mass,
time,
time,
Kelvin,
Kelvin,
candela,
candela.
um,
There are these are 5. 2 are still remaining. Okay. Well tried. If you could even say 5. This is a
luminous
table.
intensity.
This is the table that has the 7 fundamental physical quantities along with their units and their symbols. The first one that we can see is length. The first fundamental physical quantity is length. What is the unit or the SI unit of the length? SI unit of length is meter and it is denoted by the symbol M. So you see there are 3 columns here, yes or no? But when you're going to make it in your books, you will make one more extra column. One more extra column you will make. So make 4 columns and I'm going to give you, and I'm going to also create a space over here to make one more column. I will create space to make one more column here. And the name of that column I will tell you just in 2 or 3 minutes. So I'll make one more column here. I have also added a column. Okay, so the first physical quantity is length, SI unit is meter, and symbol is small m. The second fundamental physical quantity is mass. Mass. SI unit is kg or kilogram. The symbol is kg. We all know this, yes or no? The third one is time. MLT, everyone knows. SI unit is seconds. Symbol is S. Sometimes we write it as SEC, but writing S is good enough. The fourth one is electric current. Have you heard about electric current? Can I have some reason that we have heard about electric current? Students in the class? Only one student has heard about electric current. We know about electric current. Class number 2, no one knows about electric current. Do we know about electric current? Yes or no? You can just raise your hands like this so that I understand. This is the way to communicate. Yeah, great. Electric current, the SI unit is ampere and the symbol is capital A. Fifth one is temperature. All of us know about temperature. The SI unit is Kelvin. Sometimes we use a different units, degree Celsius, that is in the CGS system. The symbol is K. Amount of substance. How much is the quantity of substance? That is used in chemistry. It is also used in physics. It is also used everywhere. Mole, MOL. Luminous intensity, candela, CD. Do we all understand this? Have you heard about this? Yes or no? Yes, you would have heard about this. Great. These are the 7 fundamental units, but I have also told you that there are 2 supplementary units. Yes or no? I've also told you 2 supplementary units. So these are the 7 fundamental units. These are the 7 fundamental units. Anyone has any idea what are the 2 supplementary units? Anyone has any idea what are the 2 supplementary units? These are the 7 fundamental.
Plane angle, solid angle, sir.
Yes, that is correct. And that is what you are going to again create a space for those 2 units. I don't have space at the bottom, so I'm going to create space at the top. The 8th one, which is the supplementary unit number 1, is plane angle. Plane angle. The SI unit is radian. and you can call it as RAD, radian. Then the next supplementary unit is solid angle, steradian. Solid angle we are not going to use. Plane angle we are going to use. Solid angle we use in 12 standard. So whenever we require it, we will get to this plane angle, the angle that you know. Remember, the SI unit of the angle that have you used is radians and it's not degrees Celsius. Not degrees Celsius. It is not degree. It is radian. And you know the relation between radian and degrees? Yes or no?
Yes, sir.
I probably told you in the basic class. What
Yes.
is the relation between radian and degrees?
Sir, 1 radian equals to 180 by pi degrees, sir. Pi by 180 degrees, sir.
Okay, so you can remember it like this, bacha. 180 degrees is equal to pi radians. Will you remember this? Short note that you will write, because this thing will come to us in many ways. 180 degrees is pi radians. So these two units on the top, marked by this red color. What is the difference between the red units and the blue units? The blue units are the fundamental units or fundamental quantities. The red one, they are not fundamental. They are not known as fundamental. They are known as the supplementary units. So now I have a system, the SI system, that we use 7 fundamental quantities and 2 supplementary quantities. Are we there everywhere? Do we understand this? Yes or no? Raise hands will give me more confidence that we are done. And we should not forget the 7 fundamental and the 2 derived units at all, because there is always one question at least that comes from this chapter, which is the easiest question in the entire paper of physics. One question is going to come based on this, whether it is a JEE main ka exam or it is NEET, or for that matter it is JEE advanced. One question will always be there, at least, if not more, from this particular chapter. So unless and until you understand the basics of it, beta, it might become a bit tough. Everyone has understood this? Everyone has written these 7 units? Yes or no? Can I have raised hands? Everyone has written this. The notes are the most important aspects of your preparation. If you are making good notes from day one, which is today, no, which was yesterday, day before yesterday, you are doing well. Now, I made one more column extra. Can anyone tell me what is going to come in that column? This is called guessing game. Guess the future. Can you see the future? What is going to come in that 4th column?
CGS units.
Nice guess, but no, I am. We are only concerned with 3 units here: length, mass, and time, because the other 4 units are going to come at a later part. And I have already told you length, mass, and time ka CGS unit. So 4th column will not have the CGS unit. Any other guesses? Remember what is the name of this chapter?
Units and dimensions. Sir, dimension formula, sir.
Dimension. Dimension is going to come in the 4th column. But before going on to that dimension wala part, we have to understand what do you mean by this dimension. Now again the baton passes on to you. Can anyone tell me what do you mean by dimension of a physical quantity?
Sir, the
What do you
length
mean
mass
by
time, sir.
dimension of a physical quantity? Yes, beta.
Sir, we include in that length mass time, sir. That is dimension formula.
Okay, so if I just take you back, for example, if I have to tell you the position of any particle in where that particle exists, what I need to tell you? I need to tell you the x coordinate, yes or no? I need to tell you the y coordinate, I need to tell you the z coordinate, and I need to tell you at what time it is where. So if I have to locate any particle in space where it is right now, I'll have to tell you the x coordinate, the y coordinate, the z coordinate, and the time coordinate, right? So these four becomes their dimension, three dimensions of space and one dimension of time. Have you heard this? We live in a four-dimensional world. Three dimensions of space, length, breadth, height, and one dimension of time. So with this, you can locate any particle where it's there. Now, when you talk about dimension of a physical quantity, you can understand it by this dimension of space and time. If I have to locate any point in space, I have to tell you the x, y, z, and time coordinate. Similarly, if I want to understand what a physical quantity is, how that physical quantity comes into existence, we'll have to tell you, I have to tell you its dimensions. What is its x dimension? What is its y dimension? What is its z dimension? What is its t dimension? But remember, it is not a point in space. So instead of telling you x, y, z, and t, any quantity which is a derived quantity, any quantity which is a derived quantity is made up of these fundamental quantities. Do we understand this? Yes or no? We have only seen 7 quantities and 2 supplementary units. Obviously, there are a lot of quantities, innumerable quantities. Velocity, acceleration, force, momentum. There are a large number of physical quantities which are not derived, which are not fundamental, they are derived. Now, if you want to understand how a derived quantity is made, I have to tell you its x, y, and z coordinate. The x, y, and z coordinate of a point tells us the position of the point. Now, instead of x, y, and z coordinate for a physical quantity, because a physical quantity is not made up of x, y, and z, it is made up of fundamental quantities. So I have to tell you which all fundamental quantities are present. That becomes the dimensional formula of a derived quantity. The dimensional formula of a derived quantity tells us what all fundamental units, what all fundamental quantities this derived unit is made up of, and what powers they are raised. Now, x, y, and z axis, we have called one axis as x, one as y, one as z, one as t. So I've given x, y, and z axis names. I've given a dimension to x, y, and z. X axis is called x, y axis is called y, time axis is called t. Similarly, I have 7 fundamental quantities. I have 7 fundamental quantities. So I have to give 7 fundamental names. Yes or no? I'll have to give them 7 fundamental names. And those fundamental names which I have given to these fundamental quantities become the dimension of these fundamental quantities. Do we understand this? Yes or no? So x, y, z, t, there are only 4. But now I can't do with 4. I need more. How many more I need? I need 7. I need 7. And so I have 7 fundamental dimensions. If you want to call them, you can call them 7 fundamental dimensions. And what are the names of these 7 fundamental dimensions for length? First of all, I will write the heading dimension. Oh, space is less, but I will just write it. Dimension. For length, we use capital L. Do we know this? Yes or no? For mass, we use capital M. For time, we use capital T. X, Y, and Z, L, M, and T. For electric current, ampere, we use capital A. For temperature, you sometimes use K, sometimes you use theta. Whatever, you understand, Kelvin or theta. For amount of substance, we use MOL. For luminous intensity, we use CD. So now I have 7 fundamental quantities, I have 7 fundamental units, and I have 7 fundamental dimensions. Do we understand this? Yes or no? Please raise your hands. Great. I'll give you 2 minutes to note this down.
Hello, sir.
Writing completed.
So you have completed
Completed
that?
writing.
Okay, I'll give
Hello,
you
sir.
1 more minute. Write
Sir.
it down. Don't worry. I'll give you time. Don't worry. Write it down.
Hello, sir. Hello. Hello, sir.
Yes.
Sir, I have a doubt, sir.
Yes.
Sir, dimension formulas we have to represent it in capital letters or small letters, sir. Actually, there you represented in
Capital letters. I've written the dimension in capital letters. No, beta?
sir means
I've written the dimension in capital letters. I have not written in small letters. Okay. So you'll have to represent all these dimensional formulae in capital letters. Is it clear, beta?
oh, yes, sir. Thank you, sir.
Okay. So have you noted it down, beta?
Sir, hello, sir.
Yes, beta.
Sir, for these supplementary angles, there is no dimension, sir.
No, supplementary has no dimension, beta.
Okay, sir.
Note it down. I'll give you time. Don't worry. Once you are done, please let me know so that I can move ahead. Take your time. I guess you need time to write. That is not a problem.
Sir, completed.
Completed? Okay.
Yes, sir.
Then I will move ahead. With the next thing. Now remember, no one is going to ask you the definition of dimension. What do you mean by dimension? No one asks you that definition, but since we are dealing with dimension, it's better if we write the definition also. Now, how do you define this dimension? The definition comes on your screen right now, which is what I said. What is the dimension of a physical quantity? Dimension of a physical quantity are the powers or exponent to which base quantities. What do you mean by base quantities, better here? What do you mean by base quantities?
Sir, which are fundamental, sir.
Yes, base quantities are fundamental. So up to what power you raise these fundamental quantities, so that you get any quantity is known as the dimension of that physical quantity. No one is going to ask you the definition, but since I'm a purist, I want my students to know what is the definition of dimension, and that is the reason that I am giving you to write this. And since it is a definition, you have to write it in the way that it is written. And I hope you have understood this. Dimension of any physical quantity is the power to which base quantities are raised so that you get that physical quantity. That is known as the dimension of that physical quantity. I hope it is clear to everyone. Ray science will give me more confidence that yes, sir, we are there in the class doing stuff which is good. Now, simple things. Since we know what is a dimension, we can also create a small term known as the dimensional formula. Now, without reading what is there, can you tell me what will be a dimensional formula? What would be dimensional formula? So in simple language, what would be a dimensional formula? What would be a dimensional formula? Now, dimension of a physical quantity is simply the power to which fundamental quantities are raised. Now, let us talk about the dimensional formula. And tell me any physical quantity that you know. Tell me any physical quantity that you know.
Sir, length.
Okay. So length is a physical quantity. Oops, I should have used. Length is a physical quantity, but it is also a fundamental physical quantity. What is the dimension formula of length? It is simply capital L in this type of a bracket. This becomes the dimensional formula for length. Now, length ka dimension formula is L in square brackets. If I talk about speed, everyone has heard about speed. Yes or no, beta? Everyone has heard about speed. Now you also know what is speed. Distance divided by time. This is probably you have heard. So now you can tell me what will be the dimensional formula of speed.
Bracket of V, sir.
Yes, beta?
Bracket of V, sir.
L into T. L divided by T. Length divided by time. We don't write it as L by T. We will write it as LT minus 1. Are you getting the concept correctly, beta? You will have to understand how speed is made. It is distance divided by time, and therefore the dimensional formula for speed becomes LT minus 1. L standing for length, which tells us the distance. T standing for time. It is length divided by time, distance divided by time, and therefore the formula is LT minus 1. Do we understand this? Yes or no? Everyone. So this is what it is described here in language. The dimensional formula of any physical quantity is that expression which represents how and which fundamental quantity is included. In speed, length and time are included. LT minus 1. In speed, length and time are included. LT minus 1. Everyone there with me in the class? Yes or no? This is known as simple dimensional formula, or sometimes we can also call it dimensional equation. If it is written in this form, we just call it dimensional equation, because now it's not a formula. You can call it formula or equation, doesn't matter. No one is going to ask you the details of what is a dimensional formula and what is a dimensional equation. They both basically mean the same thing. Have you written this, bacha? Dimension formula. You may not write the entire definition. No one is going to ask you what is the definition of dimensional formula. You just have to understand how you are going to write the dimensional formula of various physical quantities. Your mic is not working. Is that so? Okay. Is there any doubts that you have? Remember, whenever definitions are important, I'll tell you that this definition you have to remember. If definitions are not important, I'll tell you that. No one is going to ask you what is the definition of a dimension. No one is going to ask you what is the definition of a dimensional formula. No one is going to ask you what is the definition of a dimensional equation. You just have to understand what is it. Do we get this? Can I move forward? Yes or no?
Sir, please can you wait a minute, sir?
Yes, okay, I'll wait. This is how we understand what is a dimensional formula. To make any dimensional formula of any physical quantity, you must know how that physical quantity is derived, what all quantities it has. If you don't know that, well, you will not be able to find out the dimension of that quantity. So in the coming 2 years, you will be coming across a lot of physical quantities. You'll have to remember them all. You'll have to remember their definitions. Then you will be able to make out their dimensional formula. So not all physical quantities we can discuss. We are only going to discuss those physical quantities which are going to come very, very soon. And the quantities which are not going to come very soon, we are probably going to avoid them, because when they come, then you will be able to make out their dimensional formula. Yes or no? Can you move ahead? Everyone is done? Can I have raised hands? Right. So now one more thing comes, dimensional equation. Again, no one is going to ask you this definition. Dimensional equation is what? As I said, I gave you the dimensional formula of speed. I write speed as LT minus 1. So instead of speed, if I write V as speed or velocity, and I write it as LT minus 1 in bracket, this thing now becomes the dimensional equation. Doesn't matter. You just have to understand the dimension. Now remember, here M is written as 0. Now the correct way of writing any dimension is you have to write all the 7 dimensions. No, all the 9 dimensions you need to write. But what we do normally, beta, is the dimensions which are not there, we neglect it. Instead of writing 0, 0, 0, we neglect it. For example, in speed, we don't have mass. Mass is not there in speed. So as you can see, I have written it as LT minus 1 here. And I have neglected that mass because mass is not there. Why I need to write it? But correctly, theoretically, what you should have done is you should have written mass raised to the power 0, L T raised to the power minus 1, then Kelvin raised to the power 0, then ampere raised to the power 0, then mole raised to the power 0, then candela raised to the power 0, then radian raised to the power 0, then steradian raised to the power 0. It would have become very tedious. Don't want to write all these things. So we'll only write those dimensions which are appearing. Do we understand this? Yes or no? This thing becomes the dimensional equation. We'll only write what is there and we will not write what is not there. Otherwise, it becomes pretty tedious task, as everyone can see. So we will only be concerned of those dimensions which are appearing. Now is the time that we recollect. Now is the time that we recollect some quantities that we already know and try to make out their dimensions and also make out their units. Can we do this? Can you move ahead? Yes or no? Okay, so we are going to move ahead. You don't have to write the definition of dimensional equation and dimensional formula. I just told you.
Sir, wait a minute.
I've just told you that it is not important. The only thing that is important is that you understand what is a dimensional formula or what is a dimensional equation. These definitions are not going to come anywhere. No one is going to ask you this. Okay? Important thing is you understand what is a unit, what is a dimension, what is a dimensional formula. Shall we move ahead?
Wait a minute, sir.
Okay?
Sir, 1 minute, sir, please.
Okay, take your time. Okay, shall we move ahead now?
Yes, sir.
Great. Now we have gone through, we have understood what do you mean by a dimensional formula or a dimensional equation. What we are going to do now is go back in time and look at some dimensions, some quantities that we already know. For example, number one quantity, distance. Yes or no? What is the SI unit of distance? Can anyone tell me? What is the
Sir,
SI unit?
meter, sir. Meter, sir.
Meter. And what will be the dimension of distance now? Since we know dimension, it will be L simply. Yes or no?
Yes, sir.
So distance, SI unit is meter, dimension is L. The next thing is displacement. Have you heard about displacement? Yes or no?
Yes.
Displacement. The SI unit is also meters and the dimension is also L. As you can see, a very important thing here, distance and displacement, they both have the same SI unit and they both have the same dimension. Does that mean that they are the same quantity?
No, sir.
No. A very important result that you must remember, there might be physical quantities which have same units, which have same dimensions, but they are not same. They are different. Distance is not same as displacement. Speed is not same as velocity. Work is not same as energy. Work is not same as torque. There are many physical quantities that are going to come which will have the same unit, which will have the same dimension, but they are going to be absolutely different. Do we understand this? Yes or no? And I hope everyone is noting down these dimensions as I speak, because time is a liberty that we don't have. So we will have to write as we talk. The third physical quantity, what is that? Speed. Have you heard about this? Yes or no? Speed, and I write in bracket velocity because we know that they will have the same dimension. Speed slash velocity, the SI unit is meter per second and the dimension is LT
Sir,
minus
minus
1.
1.
Now you will say, sir, why not written is as L by T? But it is not written like that. It is always written in powers and not divided by. Therefore, it is written as LT minus 1. The fourth one that we are going to do is acceleration. Acceleration. What is the SI unit of acceleration? Meter per second square. Now, can you tell me what is the dimension of this, gentleman?
LT minus 2, sir.
LT minus 2. So now you know how it is made. Since we have come to acceleration, let us talk about force. Force. What will be the
Newton.
SI unit of force? We call it Newton. Yes, yes, we call it Newton. But in terms of meter and seconds, what will be the SI unit of force? Remember how force is made.
Sir, hello, sir.
How force is made.
Sir, actually, yes, Newton is equals to kg meter per second square, no, sir.
Right. So if you remember, force is mass into acceleration. Do we remember this? Yes or no? So you multiply acceleration with mass. Acceleration is meter per second square. Mass is kg. So it becomes kg meter per second square. The dimension now becomes the first time m comes into the picture. M L T minus 2. Are you there with me, everyone? Yes or no?
Yes.
Great. Now, it is the time that we understand that sometimes this kg meter per second square, which is definitely the SI unit of force, we also call it by one other name, and that is known as Newton. N. So 1 Newton or 1 N is equal to 1 kg meter per second square. That is the SI unit of force. Instead of calling it kg meter per second square, you can also call it Newton. Do we understand this? We also have one CGS unit of force, which we'll discuss when we come to that. Let us now concentrate on SI units force. Okay. Do you know any other quantities that you have heard about? Yes, tell me.
Um,
Since you have heard about force, you must have heard about work done. Yes or no? Work. Have you heard about work?
yes, sir.
Now you have to remember what is work. How do you get work? Do you remember the fundamental definition of work?
The dot product of force into displacement, sir.
Shabash, it is the dot product. Let us not get. Okay, you have done vectors and scalars, right? So you know what is a dot product? Yes or no?
Yes, sir.
It is a dot product of force with displacement. Let me just write it as force into S right now because I'm only concerned with the unit and dimension, nothing else. Now you can make out, since you know how force, from force, how do you get work done? You should be able to make out its SI unit and its dimension. Can you tell me what is the SI unit and dimension of work done? Look at the board, look at it in your books. You should be able to tell me what is the SI unit of work and the dimension of work. Anyone? No one? No one can make out? So, I will help you out then if you can't make out. Work is force multiplied by displacement. Force is kg meter per second square. So I multiply 1 meter more and I will get kg meter square per second square. So I have just multiplied 1 more meter, 1 more displacement, 1 more distance if you want to say it that way. And now I have the SI unit, and now you can make out the dimension ml square t minus 2. Do we understand this? Can I have raised hand that we understand this? This is how it is to be made. Yes or no? The second smaller class,
Yes,
the
sir.
new class. Yes. Now you understand that the SI unit of force can also be called as Newton. Then you can make out another name for work, the SI unit of work. The SI unit of work can also be called as Newton is force, and you multiply.
Joule, joule.
You can also call it as Newton meter. Yes or no? Newton has been multiplied by a meter. We get Newton meter. Now this Newton meter also has one more name, and then that is known as joule. So now you see how we are building up point by point. Newton meter is also known as joules. And since you know joule, joule is also the SI unit of
What, sir?
energy. Energy. Yes or no?
Sir.
That means work done and energy. So I will write slash energy. They both have same SI unit. They both have same dimension, but definitely they are not the same physical quantities, but they have the same SI unit and same dimension. Do we understand this? Yes or no? Can I have some raise hand that we understand this? Now you should also
Yes, sir.
understand that any type of energy, and we will be coming across a lot of type of energy. For example, potential energy. For example, kinetic energy. We will also come across heat energy, light energy, electrostatic energy, magnetic energy, solar energy. All energies will have the same dimension and they will have the same unit. Do we understand this? Yes or no? You
Yes,
understand
sir.
this? Okay, then this we will continue this thing in the next class. I hope everyone has noted this down.
Thank you, sir.
I have a list of all these physical quantities that we have to go across, and I'll share with you that list. And in the next class we will be dealing with more physical quantities, and we will see what all things can be done with this dimension. We call it dimension analysis. So we'll see the benefits of dimension analysis in the next class. Take care, and I'll see you in the next class. Bye
We will
bye.
meet on Monday, sir.